Hi, today I want to talk with you about the fundamentals of a private cloud and what are the success factors of designing a winning cloud offering. For a long time, enterprise users wanted their IT department to look more like Google, Amazon, and other public cloud or SaaS providers. The public cloud richness of services, simple catalog, easy access, good SLA, and fast time to deliver challenged IT department in the race to the cloud era. Virtualization, the latest IT revolution, disrupted the industry and created a whole new set of tools to design better and more agile data centers. But how much of that revolution actually influenced the end users, both developers and corporate workers? From the user perspective, not a lot had changed. They still got mostly the same apps and response time from IT department. Yes, virtualization did have a deep impact on IT ability to deliver and manage hardware resources, but from an application perspective, they still use the same build, provision, monitor methods to run operations. This led IT department to seek for new set of tools that will help them to increase the user experience and look and feel of their cloud. VMware started this journey with its customers a couple of years ago, with the introduction of software-defined data center approach that enhanced the private cloud initiative. This approach enabled IT to expose virtual infrastructure construct of compute, network, and storage while controlling resources consumption and distribution. SDDC had a huge positive impact on developers by allowing them to abstract their own environment and push and pull it from the central catalog. Although this was a breakthrough in private cloud service delivery, there was some challenges, especially around designing the application and orchestration layer, managing service deployment, and connecting the cloud services to the evolving agile development world. Think of it as delivering electricity. We have a big automated and optimized power plant. We also have good infrastructure to deliver the electricity to the homes. But without the ability to turn electricity into something useful like light, heat, entertainment, and communication, it would be useless. When we start designing a private cloud, we first need to abstract and architect our data center so it can support the agility and scalability needed from a cloud solution, just like building the power plant or an infrastructure factory. The infrastructure factory should include all aspects of the data center like compute, network, storage, security, and policy. vSphere, NSX, vSAN, and EVO-Rail are all part of the solution to deliver the best-of-breed, most agile and complete data center for the next generation private cloud. They enable an agile cloud infrastructure with the ability to virtualize and manage compute, network, and storage in the same abstraction layer and with the same toolset. The preferred approach is to virtualize all data center components. If for some reason something cannot be virtualized, you should be able to automate it in a very agile way so the resources consumption is transparent to the management and service layer. Then comes the very important service abstraction layer. This is what you actually expose to the end users and will give them the ability to abstract and consume cloud services. You can think of it as a consumer side of the power plant: electric light, heater, air condition, and television. Remember, the end users only see your service abstraction layer. They don't really care how you provision them, on what hardware, with what tool, and in what architecture, as long as they work as expected. It's your responsibility to make the cloud data center scalable and agile in such a way that almost every action the user take will be transparent to it and will have no impact on the service and other users. To learn more about designing cloud infrastructure, visit vmware.com and search for VMware Validated Design. Now let's focus on the real cloud challenge: creating valuable services for end users. At the end of the day, your end users only care about three things: find what they need in the service catalog, get it as fast as they can, get the best SLA out of it. These three characteristics are essential for any cloud provider, but for most IT departments are still challenging. Let's find why and how to achieve and meet these requirements. First thing first, if you want your user to use our cloud we need to give them services that are of value for them. Giving a secretary a VM or giving a developer a network or storage pool might not do the trick. We need a mechanism that takes all service components and give us the ability to build a blueprint that logically describes the architecture, automation, and security needed to deliver the service. This mechanism will be easy to use and have the same abstraction for all services. With vRealize Automation 7 Converged Blueprint Designer, we can design almost any service we need and publish it to the service catalog very easily. It abstracts all service topology, from VM, network security and storage, to application orchestration, third-party components needed to deploy the service. The blueprint is described with a simple YAML file, giving the ability to fulfill the infrastructure as code functionality. With the help of CLI called Cloud Client, we can import and export it to multiple systems. Infrastructure as code is a great functionality that enables us to quickly extract and change blueprint with version control software in standard development framework. The Converged Blueprint can also abstract public cloud services from different vendors. This gives us the ability to achieve the goal of being a broker of services and expand our internal service with ones from public clouds. So after we have the ability to abstract services easily and publish them, now let's talk about how to do it fast, agile, and with confidence. Service development is just like developing an application. Most services will have logical object, binaries, script, database, scheme, and even multiple code fragments. So practicing development methodologies, we first need to have a clear separation between development, test, and the production environment. We will develop our services in the development area, then test it automatically in the test environment to see if it has the right functionality and perform at scale, and only then we will move it to production area. While taking into consideration that users will want to use our cloud, it means that we will need to build lots of services and maintain them continuously. VMware CodeStream for IT DevOps can help us to do that. It can help us to implement agile methodology in service development with the ability to capture, test, and release almost any part of the service. VMware CodeStream can also help us automate the developer continuous integration and deployment pipelines and share them back as a service. This will free the developers to write code and will enable the IT team to be a true ops part of the DevOps methodology and culture, giving valuable service to developers. Now, after we identified and created some valuable services and discussed how to deliver them fast and agile, let's discuss the SLA part. A true SLA in agile environment comes from a tight feedback loop, where we continuously monitor the service behavior and improve its performance by doing small changes in its design or in the infrastructure it runs on. For the monitor part, we use our operation suite, vRealize Operation, and vRealize Log Insight, a solution that can give a real and accurate statistic on service abstraction and behavior deterioration or improvement. All monitoring service and infrastructure changes will be transparent to the user and will not interfere with service deployment and operation. With managing a closed-loop feedback, we can monitor service SLA continuously and make small changes in service abstraction or in infrastructure to improve SLA. This service methodology and definition applies to the current second-generation application. But what about the third-generation application? For the third-generation application, we have two solutions. The first one runs second and third-generation apps side by side on vSphere and is called vSphere Integrated Containers. vSphere Integrated Containers will give you a very fast ticket to the container and microservices apps. It creates a virtual container host that exposes a Docker API to the developer, but at the same time run containers in a well-known VM form factor, giving the IT operation the ability to manage it with the same tools and methodology they are currently using. The second one is called Photon Platform and is the first of its kind native platform to run containers. It can create and expose multiple containers API such as Kubernetes, Swarm, and Mesos, and also act as a platform for known platform as a service solution such as Pivotal Cloud Foundry. Photon Controller does all that with great simplicity, scalability, and operation control. Both solutions can enable developers to explore and run third-generation apps fast and easy with the support of a trustable and mature company as VMware. The last part I want to discuss is the end-user connectivity. End users today use different tools, services, and platforms to work and be creative. We as IT need to embrace this change and give the users the freedom to choose where and when and how they want to connect and run cloud services. VMware End User Computing suite of products give a set of tools that enable remote and secure user connectivity to all organizational services while keeping the organizational policy in control. Whether it's remote computing, policy enforcement, secure email, or mobile control, it's all covered under the EUC suite. To conclude, we'll learn how VMware enables a new approach to design and build a next-generation cloud with VMware tools and architectures. To discover more, catch the nearest VMware expert and he will be happy to continue the discussion. Thank you very much.